Hello friends, in my this video I am going to discuss about safe prime number. Okay, so we all know what is about prime number. That is, the prime number is such number which is divisible by 1 and that number itself. Like you consider 5 is divisible by 1 and 5. You consider 7 is divisible by 7 and 1 only. For all other values it is not divisible, right? So basically that is called prime number. Now the meaning of safe is what? That's what we have to understand. So see, the definition of safe prime number is a safe prime number is a prime number of the form 2 into p plus 1 where p is also a prime number. That means what? Suppose you consider 5. So 5 is a safe prime number. Why? Because you can express 5 as 2 into 2 plus 1 and you consider just this 2 value. In general 2p plus 1, here p equal to 2, you consider p, here p is equal to 2, p is nothing but here prime number because 2 is one prime number. Like 7 is equal to 2 into 3 plus 1, 6 plus 1, right? 3 is prime number. 11 is equal to 2 into 5 plus 1. That means what? See, 5 is prime number, so that 11 is safe prime number. Okay, so one number, if only if one number is said to be one safe prime number only if it satisfies this particular condition, that is it must be one prime number itself obviously, and then further it should be expressed in terms of this, that is 2 into p plus 1 where p is also a prime number. Okay, like you consider the prime number 2. See, 2 is a prime number but it is not a safe prime number because you cannot express 2 as 2 into p plus 1, right? Because see, you there is no such p value, so that you can no such prime p value, so that you will get 2p plus 1 equal to 2, right? That's what I mean by the safe prime number. Okay, so you can search in Wikipedia also and you can get a detailed explanation about this. The safe prime number from Wikipedia. A safe prime number is a prime number of the form 2p plus 1 where p is also a prime. Okay, like your sequence is given 5, 7, 11, 23. Okay, 13 is not a safe prime number, right? Because see, if you take just let me write here 2. Let me write all the prime numbers from 2 to 13. See, now 13 cannot be expressed as 2p plus 1. If you want to express 2p plus 1 equal to 13, that is p should be equal to 6, right? Because 2 into 6 is 12 plus 1 is 13, but 12, whether 12 is a prime number? No, 12 is not a prime number, right? So basically 13 is not a what? Safe prime number, like that. Okay, so in my this video what I am going to discuss that such program which can work out this safe prime number in MATLAB, okay, or you can implement same logic in C or C++ or Java or Python, whatever programming language you prefer. Okay, so see, very simple. Step 1, take input from the user. Obviously you have to take the input. Then step 2, check the input is prime or not. If the input from the user itself is not prime, then how or why you are going to safe prime again? Then and there you can conclude that it is not itself prime number, so there is no question of safe prime, right? Then store all the prime numbers lesser than the input in a particular array. So what will happen? First you have taken input from the user, then you are checking whether that particular number is prime number or not. If that number is prime number, then you go to step 3 and you store all the prime numbers which is lesser than the particular input prime number in an array, and then you extract element the array and you just check whether this condition is satisfied or not. There is 2 into that particular array element plus 1 equal to your input or not. If it is satisfied, then well and good, that now input is safe prime, otherwise that is not a safe prime. That's all. So here I have written the MATLAB code. You can see CLC clear all close all. Obviously we have to write. You can write warning of also, no issue in that, or otherwise if you want you can ignore this also. The next equal to input enter the number. First we have to take input from the user, then y equal to one empty array we have defined just to store all the prime numbers which are lower than x value or input number. Okay, then QAM equal to 0 we are defining because we need one counter to check whether prime number or not. Then in this particular for loop here we are checking whether the input is prime or not. So for RE is one variable we have taken, which is taking value from 2 to x of x minus 1 for checking whether x or input is prime or not. If remainder of x comma RE equal to 0, increment the counter. Okay, if any case in any case if remainder comes as 0, that means that is not a prime number. So to check that, we are incrementing the counter. Okay, in this for loop. Then if QAM equal to 0, that means what? That means it is a prime number. Then counter else part will be here. See, at the end I have written else. Display not a prime number. Okay, so basically if QAM not equal to 0, that means that is not a prime number. If QAM equal to 0, then see what we have to do. Then as I have told you, see what this the next step. Store all the prime numbers lesser than the input in a particular array, and the array we have already defined here y as one empty array. That's all, just store that. So for I equal to 2 colon x minus 1, why x minus 1? Because we don't need to take our loop up to x, right? Just we have to store all the prime numbers lesser than the input. So m equal to I, then c equal to 0 we are defining. Then again we are checking whether that particular m is one prime number or not. Then again counter checking method, that is if c equal to 0, that means that I is a prime number. Then we are storing that in y empty array in this if, okay, and in this for loop. Okay, then d equal to 0, again one counter we are defining, and see, not counter, this is one variable. So for I equal to 1 colon length of y, that is it will take the it will traverse in the array of y if 2 into y of I plus 1 equal to x, that is if condition is satisfied, then increment the d value. Okay, then if d equal to 1, because only for one particular case the condition will be satisfied, obviously. If d equal to 1, display yes, that is safe prime, else display no, that is not a safe prime number. And this else part is for the counter of the if condition, where we are checking whether the input is prime or not. Else display not a prime number, so there is no question of safe prime also. So evaluate selection, enter the numbers. Suppose let us give 5. See, yes, this is one prime number, a safe prime number. Suppose let us give 13, as I have shown you. See, 13 is not at all a safe prime number. Okay, fine. Now using this same concept, what you can do more, you can implement all the safe prime numbers below one particular input number, where the input is given by the user. Just you have to modify the code like this. So g equal to input 1 colon enter the number, and then x, which we are taking as input in our earlier case. Now in this particular case we have to take our x loop from 1 to g. Okay, that's all. Then rest all the whole program is remaining same. No need to worry about anything. I will post all the codes in a link. That link I will provide in the description. You can check. Okay, so suppose let me show you the simulation. Control A, enter the number. See, here I have opened one chart where list of safe prime numbers are given. Suppose let me give up to 600, and let us check what are the safe prime numbers below 600. Okay, you write in QO array all the safe prime numbers less than or equal to below less than equal to input number is stored. We just write enter. See, 5, 7, 11, 23 you can correlate with here this particular chart also. So let me make it a bit smaller so that you can easily visualize. See, yeah, so here see what are the numbers. 5, 7, 11, 23. See here 5, 7, 11, 23, 47, 59, 83. Here also 47, 59, 83. Then here it is coming 107, 167. Here also 107, 167. Then 179, 227, 263. 370, 347. Here also 227, 263, 347, like that. And then here in the lower part, here you will get some more numbers. 359, here 359, 383, 467, 479, 503, 563, and the last is 587. Where also here also in the chart also you are getting 20th safe prime number. Okay, so basically using this simple modification, using the for loop, we can implement such program which will print all the safe prime numbers lesser than or equal to our input number. Okay, so basically this particular question is also solved. And one more, you can extend this particular program, that is extra safe prime number. What is meaning by extra safe? Extra safe means already the prime number is safe, you have to make it extra safe. That is, write a function to determine if a positive integer n is a safe prime in which p, the prime number, is also a safe prime. That means what? Suppose you take input from the user, suppose n is the input from the user, then n is a safe prime. Okay, and you got p, the prime number which is following this particular criteria. Then you have to further check whether the p, that prime number, is also safe prime or not. That is, that in this way the n will become extra safe. Okay, this extra safe means nothing else, just you have to use this step 3 and step 4 once more. Okay, like repetition of this step 3 and step 4, nothing else. All rest of the program is same only. Again, I will post that particular program in the link. That link I'll provide in the description, you can check there. Okay, and just try to understand the algorithm, because algorithm is most important. Program you can implement according to your choice, whether in Java or C or C++ or Python, but the understanding of algorithm is important. The safe prime and extra safe prime, just have a clear idea. These are very important questions related to prime numbers. If in interview or in your programming related course in your engineering, they try to give some questions related to prime number, they can twist the questions like this. Okay, so have a practice on these questions also. Okay, I hope you have understood this. This is all for this video. Thank you for watching, and for the program, don't forget to take the link. Okay, thank you.